My last video, my calculator got stuck for some reason. So let me get my calculator out. So menu run. Okay, so where were we? So I told you that we can do this on a calculator. You can change from the polar form. This is the polar form to the rectangular form by using the calculator. The calculator will give us this answer. But even though the calculator does give you the answer, you should know how the calculator works. Okay, that's what always my focus is. So you go to option, then you press F6, then you press F5, that's angle, and then again F6. So remember lots of steps. So you want to change this into rectangular form. That's the question, isn't it? So the question is change it into rectangular form. So again, you have to remember you have to go rectangular form, and they're asking you what's the polar form. So you type in 2 comma, okay, now I forgot I had to change this into degrees first, okay, because we're working in degrees. So go to degrees first, exit, and so 2 comma 60, close the bracket. So this is your x, or this is the real part, that's 1, and this is 1.73, okay, and 1.732 or whatever this number is nothing but root 3. I'll show you. So shift, okay, exit, okay, so shift root 3 is 1.73, and I told you cos 60 I know is half, which is 0.5, and sin 60 is root 3 over 2. This is good to remember for calculus students. Cos sin 60 is root 3 over 2. How did I get this number? So if you go shift root 3 divided by 2 will give you the same number. Okay. Now moving on to the next question. You want to multiply P and Q and to write in this form A plus B root 3. So P is 3 plus, so this is, it'll do a little of algebra, so this is 3 plus 2 root 3 times 2 minus 3 root 3. So to simply expand as we expand brackets, so this is 3, so I'll do more steps, so 3 times 2 minus 3 root 3 plus 2 root 3 times 2 minus 3 root 3. So what I've done is I've distributed 3, I've expanded 3 with this whole bracket, then plus 2 root 3 with this whole bracket. So now opening the bracket, so 3 times 2 is 6, minus, so 3 times 3 is 9 root 3, plus this is 4 root 3 minus this is 2 times 3 is 6, 6 root, okay, so what happens is, I didn't want to do that, so this is a bit difficult to explain, so let me go over this again. So this is simple, so 2 root 3 times 2 is 4 root 3. Now root 3 times root 3 is 3, okay, that means this is, okay, root 3 times root 3 is root 9, and root 9 is 3. So you're multiplying 2 times 3 is 6, and then root 3 times root 3 is 3, so this is 18. I hope it's clear. So 2 times 3 is 6, and root 3 times root 3 is 3, so 6 times 3 is 18. So this is nothing but, so 6 minus 18 minus 9 root 3 plus 4 root 3. So this is nothing but minus 12 minus 5 root 3. This is your final answer. Okay, this is called a third form, and your A is of course minus 12 and B is minus 5. Okay, I want you to do this question. I will, okay, I think we can do one question. These questions have been taken from 2003 exam paper of calculus, or the standard of complex numbers. Find all the solution including complex numbers for each of these following equations. So this is the first equation. So here to find the solution, of course the calculator again will do this, but I don't want to use the calculator. So here this is a cubic equation and you need to find the roots. So it has got one complex root. So here one technique is if you can do by trial and error. So you can say you can start with x is x plus 1 a factor. Okay, so this is a rule again. If x minus 1 is a factor, okay, then the sum of the coefficients are 1, minus 2, minus 5, and 6 will become 0. So then the sum of coefficients should be 0. So 1 minus 2 minus 5 plus 6. Is it a 0? So yes, it is a 0. So sum of coefficient is 0. So x minus 1 is a factor. Now to find the other roots, we have to do a synthetic division. I'll explain that. So what you do is you draw this is a division, synthetic division. You simply write 1, minus 2, minus 5, and 6 like this. And x minus 1 is a factor, so you have to write 1 here. Okay. So if it was x plus 1 a factor, then you would have written minus 1. Okay. Or in other words, you have to set this equal to 0, so x is equal to 1. So start with a 0. This does work, okay, there's no explanation. So what you do is you add this 2, so 1 plus 0 is 1. Then you multiply this 2, so 1 times 1 is 1. Then you add this 2, minus 2 plus 1 is minus 1. Multiply this 2, which is minus 1. Then minus 5 minus 1 is minus 6. Okay, now this is a neat way of writing or dividing. I'll explain what it means, what are these numbers meaning. So here, you always start with 1, and if you end with 0, this means that x minus 1 is a factor. So what does this mean? So this can be written, this is nothing but x minus 1 times x squared minus x minus 6. Now how did I write this? This is by looking at these coefficients. So the coefficient, let me use a different color. The coefficient of x squared is 1. The coefficient of x is negative 1, and this is minus 6. That's how I wrote this. Now how did I write x squared? Because it's x cubed and you got x minus 1 as a bracket, so you have to write x squared, or x squared, x without x. Okay, and now finally you have to factorize this. So this is x minus 1, which has two factors of negative 6. Okay, so you can't factorize this because you can't find, yes, you can find the two factors of negative 6, which gives you negative 1, which is x minus 3 times x plus 2. We'll check this on the calculator though. So the final answer is x is equal to 1, 3, and negative 2. You have to set each of them equal to 0. You should be knowing this as calculus students. So how will we check the answer? So get your calculator out, go to equations, okay, and have we done something wrong? No, we haven't. So let's try. So we go to polynomial. So this is a third degree polynomial, and type in 1 under a, because that's the coefficient of x cubed, then minus 2 under b, minus 5 under c, and 6 under d. And then you go to solve. Here are the three answers. Okay, so let me show you that. So you got 3, 1, and minus 2. So we are quite right, and you should be happy about yourself. So you can give yourself, say, 3 stars. See you in the